So we are back to talk more about Proto AI's Gestalt AI. Nick, you mentioned previously that the system uses small data models. Can you describe some of the distinctions of what a small data model is and how it's created?
Sure. So small data is defined in contrast to big data. And big data techniques are typically most useful when you're trying to solve a poorly understood problem over a really broad domain. Small data techniques are kind of the opposite. You're trying to take advantage of your understanding of a specific problem so that you can use specific data to solve it. For instance, the technique that's used to build a large language model is actually called an autoregressive transformer, which is an implementation of a neural network. These things typically have hundreds of millions up to billions of tunable parameters. In order to settle on actual values for those tunable parameters, which is the learning stage of building that model, they require a really large amount of data, even relative to the size of the model. This is generally true regardless of how big the model is. So it's sort of an inherent property to that technique. On the other hand, and for us, instead of trying to build a model that represents this function over the entire possible domain of inputs, which is mostly what a neural network is trying to do, we're instead trying to build a model that represents the function in a very specific bounded domain. And that also prevents us from trying to extrapolate out too far, which is where you start getting into uncertainty and your projections become gibberish. We create these models on demand, meaning that when a user asks a question, we build a model for that question. And rather than solving for a general input where we need this model to work for every possible thing that could be fed into it, we're only trying to work with that input in that moment. So we can be a lot more specific in how the model's built, which prevents overgeneralization, overfitting, all this other stuff that can go wrong with larger models. We use a narrowly tailored set of data in order to actually build the model, which we can only get away with because the model itself is bounded. In short, the difference between small data and big data is really how you're trying to solve the problem and what's the scope of the problem you're trying to solve. Is it a narrow question? Is it a specific question? Or are you trying to answer a whole bunch of questions at once?
So Jeff, why don't you take a second and describe how the small data local momentary model that we use solves problems differently than the big data large models? And can you give us an understandable example of what that difference is?
When I was thinking about this problem, I always refer to Winston Churchill when he said, out of intense complexities come intense simplicities. Large models assume a whole bunch of things. They assume that the point of views that are present are all present in the model. So if you change the point of view, you're assuming it's in the set. It also assumes that all the scales of the training data match the runtime data in the same scale expressions. There's a drift that's inherent in that, and it's always changing. The relationship between the input and the output also have to be correctly represented, meaning you understand the causality effects that are in the training set also exist in the runtime set. So there's a lot of assumptions built around the idea of a large language model or large model solve for any type of predictive case. The advantage of a small model, and by difference here, is that the momentary model gets rotated into the aspect of the point of view of the question. And what that does for us is it assumes that the important data is closer to us. And in this moment, the data that's less important is further away and has less effect. So it's this tuning effect that's inherent in this concept of rotation to the point of view of the asker. The second part in there is the input data determines the scale based on the data that's being seen in that moment. So the scale that's used in the local momentary model is contextually correct to the question being asked. Then the third thing it does is the cause and effect triggers which exist are also unique to that moment. Just because something is seen in general doesn't mean in the moment it's even possible or true. So it can't infect itself or inject itself into a solution where the possibilistic truth of it is no. All right, so moving on to that, kind of using a metaphor to describe this, my grandson and I both love cookies. And he got caught yesterday with my cookie bin with 2 cookies in it, looking up at his mom who said, "Hey, where'd you get those cookies? Or, did you eat all those?" And his answer was, "No, Grandpa did." Now, both these things are true, all right? Grandpa ate the cookies. So let's take that example and chase down the concept of the sugar in the cookies and understand how it teaches us how to solve a problem in this case, and how the AI solves a problem. So what we know about a sugar molecule is a form of informational expression. It has complex data in it in all kinds of states that are in motion in all kinds of ways. No 2 sugar molecules in existence are identical in the entire universe. And what we know about those is we can all understand when we eat the sugar that it's sweet. So what's happening is it's hitting our taste buds and it's turning into an informational signal that goes up to our brain. And then our brain locally encodes the signal detail into storage that's not electrical at the moment. It actually turns back to some form of matter expression. But it's not a sugar molecule. It's something else, and it's local to us as individuals. And yet, we can share the idea of sweet among billions of people because it's symbolically true. So this idea of encoding information into symbolic representation and having it shared is the foundation of how small model Gestalt data is encoded and understood inside of the environment. So when we go back to my grandson and I, we both have different life experiences. So if you look at the amount of data and what the data is for his experience with the cookie and mine, those 2 data sets don't match. But they come out to the same exact activation function. If we smell fresh baked cookies, we're heading to the kitchen. So we can share an outcome and a motivation and a direction, a prediction, even though our data is different and even though our encoding reality is different. And the advantage of a Gestalt AI is because it encodes that information in a very local way, it's symbolically complete at the moment that the data is being used to answer a question. So if you kind of boil this down to its very essence, what we're doing is we've got a model of data which is momentarily asking a question that has the right span of measurement, the right context, and the right activation function for the most likely correct answer. And we do that over and over and over again on demand.
What is the advantage of using small models to solve these problems?
So the biggest advantage that I can think of is it's a lot easier to model a specific instance of something, to model it accurately, than it is to model the entire range of possibilities. So to go back to Jeff's cookie metaphor, it's a lot easier to pick up that, hey, when the smell of freshly baked cookies is wafting through the house, these people really like cookies, they're going to go to the kitchen, myself included. Than it is to model every possible interaction with the molecule of sugar. Right? Imagine how ridiculous does that even sound, to model every possible human interaction with a molecule of sugar? It's crazy. You would need an enormous model, even for a single molecule. Whereas because we can build these models specifically to the question being asked, we don't have to have that, let's call it, global understanding of the molecule sugar. We just have to have the concept, hey, we've seen this reaction before, and someone's in the kitchen baking cookies, so they're going to want to go get cookies.
So we've been describing this idea of small data models and utilizing them as a local momentary model. So Jeff, what is the advantage of utilizing small models to solve a problem?
Well, really complex problems have a lot of inputs and variations. One of the things that Nick did for me early on is he took a very simple case and then totally illuminated and expanded the equation, the expression that was used to solve it. And it was pages long, and it was one of the smallest cases we have. So if you take a very, very intricate solve and you have to solve that intricate answer by casting it into a small data set and solving it within the context of the small data set, you now don't have to solve an uncalculatable equation to get an accurate and useful answer out of it. The power of that begins to scale. Now, the implementation detail, I'm going to kind of let Nick take a moment and explain as to why we get the leverage off of that. But I was really struck by the fact that it was already, a simple thing was already pages and pages of computation. So Nick, take it away on that question.
Yeah, so what Jeff is alluding to is I took a fairly basic question from our e-commerce application and said, okay, if I expand this out entirely algebraically for this particular instance, disregarding the fact that a whole bunch of it isn't going to be relevant in a specific moment, if I just write the whole thing out algebraically, how big is it? I put it in the symbolic algebra system on the computer and it came out, and it was about a page and a half's worth of just really ugly looking equation. Mathematically, where we get our leverage is that equation in a moment is very sparse. Most of it zeroes out. But you can only do that in a momentary context. If you're doing it in a global context, you don't have that benefit because you can't assume that all those things are zeros. You have to figure that out based on a whole bunch of other stuff. For us, that's defined in advance. We get an input and it says, here's my context, here's where I am. And with that, we can then figure out, okay, this whole chunk of the equation is now completely irrelevant. This part of the equation cancels, so it goes away. You're left with a much simpler solve that we can actually do in close to real time. Whereas if you tried to solve that gigantic mess of an equation in real time, I don't even want to think about how long it would take, but far too long is the answer.
In our next episode, we're going to dive deeper into what Gestalt AI actually is.